Alrighty, this is part 2 of solving systems of linear equations using substitution. When I was a young child, I had a singing computer. It was Adele. Now looking at these systems, we see that we have one linear equation of y is equal to 6x minus 11, and we have another linear equation of negative 7 is equal to 3y minus 2x. We kind of look out in the sense that the top equation is already solved for a variable, and that variable is y. So we see that y is equal to 6x minus 11. So we can plug the value 6x minus 11 in for y in the second equation. So let's rewrite the second equation with that new value for y. So we have negative 7 is equal to negative 3 times y. Y is 6x minus 11, and that quantity minus 2x. So we're going to start out by doing some distribution of this negative 3 across this value for y. So we're going to have negative 7 is equal to negative 3 times 6x, which is going to give us negative 18x. And then we have this negative 3 times negative 11, which is going to give us a positive 33. So we have plus 33 minus 2x. And we are going to combine like terms. So we have a negative 18x and a negative 2x, and that's going to give us negative 20x. So we now have negative 7 is equal to negative 20x plus 33. We want to solve for this variable, which is x. We see that a 33 has been added, so we need to subtract that 33. 33 minus 33 is 0, and by additive identity, anything plus 0 is itself. So if these 33's go away and get this negative 20x by itself, what we do on one side of the equation, we have to do on the other side of the equation. So we're also going to subtract 33 on this side. So we have a negative 7 minus 33, which is going to give us a negative 40. So now we have negative 40 is equal to negative 20x. When we have this negative 20 next to the x, that means it's being multiplied by the x. So in order to undo that multiplication, we need to do the opposite of that, which is going to be division. We're going to divide by negative 20x. Anything divided by itself is 1, and by multiplicative identity, anything times 1 is itself. So that's why we get this x by itself. These 20's go away, and what we do on one side of the equation, we have to do on the other side of the equation. So we're going to divide this side by negative 20 as well. So we have negative 40 divided by negative 20, and negative divided by a negative is going to be a positive. So we have 40 divided by 20, which is going to give us 2. So we have that x is equal to 2. We will write this as a point. X comes first. We have this 2. We have not solved for y yet. So we can now plug this value of 2 in for x in either equation. I'm going to plug it into that first equation of y is equal to 6x minus 11. So that means we're going to end up with y is equal to 6 times 2 minus 11. And we're just going to solve from here. We have 6 times 2, which is 12. And we have 12 minus 11, which is going to give us 1. So we end up with y equals 1. So that completes our point of 2, 1. That means if we were to graph the linear equation of y is equal to 6x minus 11, and we were to also graph the equation of negative 7 is equal to negative 3y minus 2x, then those two linear graphs would intersect at the point of 2, 1. Now in this first equation, we solved for the y to start. So I'm going to do these exact two linear equations, but we're going to solve for the second equation first. And so we have a negative 7 is equal to negative 3y minus 2x. We can solve for either y or x. I'm going to solve for x to start. So in order to solve for x, we need to add this 3y to both sides. So I'm going to get a negative 7 plus 3y is equal to negative 2x. We need to solve for this x, which means that we need to divide everything in the equation by a negative 2. So we're going to end up with 7 halves minus 3 halves y is equal to x. So now we have this value for x, that x is equal to 7 halves minus 3 halves y. So we can plug that value for x into the first equation. So we're going to have y is equal to 6 times x. And as we found in this first equation, x is equal to 7 halves minus 3 halves y. And then that quantity minus 11. So again, we're going to start with distributive property. We have 6 times 7 halves, and so that's going to give us 42 halves. Doesn't look like 42, it looks like 12. Oh, now it looks like 42. And then we have 6 times negative 3 halves. That's going to give us a negative 18 halves y. minus 11. Now, before I add any like terms, I'm going to reduce these fractions. So we have y is equal to 42 halves is going to be equal to 21 minus 18 halves, which is going to be 9y minus 11. So that's going to be a lot cleaner looking at. So now we want to get our variables on the same side, which is the y's, and we want to get our consonants on the same side. So I'm going to add this 9y to both sides just so I can get the y's on the same side. So now we have 10y is equal to 21 minus 11, which is going to be 10. So we have 10y is equal to 10. We're going to divide both sides by 10. And we're going to get that y is equal to 1. So if we write this as a point, x comes first. We don't know x yet, but we do know y. So we have this y is equal to 1. If we look back at the first time we solved it, we did get that y equals 1. But coming back to solving it this way, we can plug in y equals 1 in for either of the equations. I'm going to plug it into the first equation. So we're going to have y, which is 1, is equal to 6x minus 11. So in this case, we want to solve for the x. There's an 11 that has been added to the x, so we're going to add this 11 to both sides. 1 plus 11 is going to give us 12, so we have 12 is equal to 6x. Is 6 next to the x means that 6 has been multiplied by the x. We want to undo what has been done to that variable, so we're going to do the opposite multiplication, which is going to be division. So divide by 6, 6 divided by 6 is 1, and by multiplicative identity, anything times 1 is itself. That's why I get this x by itself. What we do on one side of the equation, we have to do on the other side, so we're going to also divide this side by 6 as well. 12 divided by 6 is 2, so we get that x is equal to 2. So when we write this point, we're going to end up with the point 2, 1. And if you look back at the first equation, when we solved it, we did get the point 2, 1.